Right, so what I'm going to do is I'm going to do a quick walk around the model, and has everybody got a copy of the model in front of them, because it would be useful to have it in front of you. So what I'm going to do is I'm going to just start by writing up an address. So that's something that I think most people would recognise as an address. So we'll start with that. Now, the first thing we can do with that address, and if you look at the model, we can break that address down into components. So I'm going to start at the components and identify components of that address string. So just quickly going through the string, we can identify that 5 is a component of that address, Hobson is a component, street is a component, we have a suburb component, we have a city component, and we have a postcode. And we can name all those components. So this is a number, this is a street name, this is a street type, this is a suburb, this is a city, and this is a postcode. And all those components go together to form what we call an address. Now, some of those can be represented in different ways. So, street could be represented as ST. ST and street spelled out in full mean exactly the same thing. They're exactly the same thing, they're just represented differently. That makes them alternative components. So if it's spelled differently but means exactly the same thing, that becomes what's called an alternative component. And if you look in the model, you can see that there's an association between a component and an alternative component. So that's what an alternative component is. It's just a different way of saying exactly the same thing. And there could be a number of those. We could have Wellington abbreviated in some particular way, which makes that an alternative component. So all those components and alternative components go together to form what we call an address. Yep. Now, because we've got a particular set of components in a particular order, we've got a component called number, a component called street name, a component called street type, suburb, city, and postcode. Those components in that particular order define what's called a class of address. And in this case, we can call this class a street address. So a class is an address which is composed of a particular set of components in a particular order. So we'll call this a class of address called street. So that's pretty much how we put together an address. It's just a set of components and alternative components in a particular order. I'm now going to write up another address. Now we can go through this address and do exactly the same thing we've just done with the one up here. We can start by identifying our components, 20, Motorola, street, Thorndon, Wellington, 6012. And we can have alternative components in exactly the same way. Somebody might have abbreviated Wellington as Wellington that way. It's an alternative component of Wellington. It means exactly the same thing. And we might have street as an alternative component here, spelt with an ST instead of spelt out in full. Alternative component. Again, this defines our address. We've got components. We've got alternative components. Those components occur in a particular order. And in this case, they're exactly the same. This address and this address have exactly the same components in exactly the same order. So they're the same class of address. They're both a street address. Now we happen to know something about these two addresses. These two addresses are in Thorndon and they're real addresses, and we happen to know that they are the same property. So these addresses both refer to the same property. So that brings in the concept of what's in the model called an addressable object. So the addressable object, that's the object which the addresses are referring, and it's a property or a building or something like that. It's a real world, something you can go to, and that's what you'll find when you get to the location of the address, a building, a property, something like that. And in this case, these two addresses refer to a residential house which is in Thorndon, and Richard has a picture of it on the screen at the back there. Yeah. Now, because these two addresses refer to the same addressable object, that makes them aliases. So this is where we bring in the concept of what an alias address is. Two different addresses that refer to the same addressable object, the same building, the same property. That means that these two addresses are aliases. So we can represent that as an association. And again, if you look in the model, you'll see there is off the address class, there is a association for alias. But the thing is, they're aliases because they refer to the same addressable object. So that's pretty much how we build up addresses. We've walked through the model. We've started it with an address string. We've looked at components. We've looked at alternative components. We've put them together to form a class. We've figured that they're related to the same property or addressable object, and that makes them aliases of each other. Now, of course, these addresses can have address points or locations of their own too. So each of these addresses can have an address point location. The thing to note there is the address point is related to the address and is separate from the addressable object. The addressable object is the building or the property. The address is the collection of components which form a class and has a point location of its own. And that point location can be in various different places. It could be on the building, it could be at the letterbox, it could be 5 metres back from the street frontage. What was the old Lynn's way of doing it? 5 metres back from the street frontage in the middle of the... Point is, an address point can have various locations, but it is attached to the address. Does that make sense to everybody? There's a quick walkthrough. So if that makes sense, I'm going to put up a couple more. I'm going to pick another address and work through another address, doing a very similar thing. 1111 Ruatapu Ross Road, Ross, Westland 7883. And I do believe Richard has a picture of this address as well. So we can go through this and do exactly the same thing that we did with the first address. Let's break it down into the components, the constituent parts. 1111 Ruatapu Ross Road, Ross, Westland 7883. And we can name those components in the same way we did before. Number, name, street type, suburb or town, locality say, and postcode. And in the same way that we did before, just for completeness sake, we can say that road is an alternative component, and we can say that maybe somebody spells Westland like that, so that becomes an alternative component. And they all form an address, and we can look at the components again, particular set of components, street. We'll call that a street address, because it's the same set. It's a set of components that form a street address. Now I'm going to write up do what we did before. I'm going to write up another address. 1111 SH6 Ross, Westland 7883. Same thing we did before. We can go through, we can break it into components. 1111 SH6 Ross, Westland 7883. And we can name our components. Number, street name, sorry, not street name, highway name or highway, suburb or town, locality, postcode. Now, the difference here is it's a different set of components, so it's a different class. In this class of address, we can call the state highway address or a highway address. But the important thing to note is they're not the same components, which means it's not the same class of address. Now we also happen to know something about this address too. We happen to know that this is also the same property. You can't see an awful lot of this property from the road, but they are the same property, which means they are the same addressable object, which means, again, that these are aliases. But this one can have another address as well. It can also be 1111 Ruatapu Ross Road, RD3 Hokitika 7883. And we do the same thing, we break out our components. We give them names, number, street name, street type, rural delivery number, mail town, postcode. So again, we can see here, actually, it's a different class again, because we've got different components. This time we've got a street number, a name, a street type, and now we've got a rural delivery number and a mail town and a postcode. And we could have alternative components in exactly the same way, but it's a separate address, it's a separate class, and we'll just call this one postal, or we could call it rural delivery, I think is actually the official term, isn't it? Yeah. But the important thing is, it also relates to the same addressable object, which means that it is also an alias. Now these things the model allows these addresses to have preferences as well. So we've now got 3 addresses for the same property, but we can give them a preference. So we can say that's the preferred one that we want people to use. And this is called preference level. So you can say, for aliases relating to the same addressable object, we can say which one of these we prefer people to use. And in the same way, each one of these addresses can have an address point. Which defines the location of the point. And that's pretty much a quick walk around of how that model works. So we started with an address, we've looked at components, we've looked at alternative components, we've looked at aliases, we've looked at addressable objects. The things we haven't looked at yet are the parent-child relationships. We've also looked at classes. It's a quick walk around the model. Now, Richard, is it worth spending the time, a few extra minutes, and going through parent-child relationships, or shall we leave it there? I guess I should first ask, if there are any questions about that, or does that make sense to everybody?
There's a lot of little components and little subtle distinctions there. So the core group probably talked about just this for an entire meeting or 2. We've got to be careful, Mike, that we recognise that it took a while for the team to grasp the model, right? And we can't expect everybody to just pick it up over a few minutes.
Can I ask you how that relates to the model in terms of what we're talking about? We're talking about address component and class, and that kind of stuff, because it's also buried in that.
Now Stephen is going to spend quite a bit of time for the rest of the meeting going through each particular class in the model and getting into more depth. This was just designed to be a quick introduction to how we use scenarios to break them down and make them work or fit them into the way this model works. As I say, starting with address, what's a component, what's an alternative component, how do we create aliases, how does an address relate to an addressable object, how do those components go together to form a class.
The other big question might be, what have we forgotten? What are the other classes that we haven't thought about? So as we mature, round out the thinking about this model and what the New Zealand profile of it would look like, how it would work. Have we covered all the scenarios that we're aware of that exist in New Zealand? And there will be ways to test for that. But for the reviewers this morning, those not so familiar with the model, that's the sort of big question that's floating around. Have we covered all the bases?
Does that give everyone a good start?
So
worth clarifying that the components in this example, we're not saying those are all of the components?
No. These components were just illustrative components in order for us to understand how the model works. One of the tasks that we've been doing is building the code lists for these components. What actually are these components? That's something that the working group has been doing, and we have a list, but we've still got a way to go to really tie down exactly what those components are. For instance, there's discussion around whether state highway is a separate component or not. But for illustrative purposes, to demonstrate that how an address was created of components and those components went together to form a class, it's illustrative.
Yeah, and like the first one, it could be unit 3 at 111.
Yeah, there are other
components.
components of an address that we haven't put up here in these examples. As Michael says, you could have a prefix of unit or dwelling or flat before the number. There's a suffix that you can have after the type, north, south, east, west, central, upper, lower. One of the areas we had a lot of discussion about was whether you can have a prefix as well. So there are other components that we haven't shown.
That's also all so far on that
Yeah.
page. That's where we have the current draft list. I don't confuse everybody by throwing that out there too much now. That's indicative of where we are in terms of our class lists, our component lists, our address position lists, our street type lists, a whole bunch of other things.
Oh, we're onto the camera phone. The key thing for me at the time, some months ago, was just solidifying the idea of this is the definition of an alternative, this is the definition of an alias, because we were swapping those terms around.
And I have created some diagrams of what I've just been through. So I put together some diagrams to show this. And these diagrams are available on Dropbox, but we could certainly print them out as well if people would like to have them print out of them.
Mike, just out of curiosity, did you consider alternative components for the street name?
The model specifically says that you're not that an alternative component is not for a misspelling of a name.
It's not a misspelling. It's the hyphen in that first example, a lot of people don't use.
In fact, you have it yourself on the third one.
Yeah, and state highway is not always SH. It's actually in full. There's about 10 different variations in
Yeah.
state highway.
So that's right. So state highway could be spelt out like that, which would make it an alternative component. Yeah, absolutely.
Okay.
Now, there's a lot of our alternative components sort of touching on this are things like abbreviations, as you can see there with Western and Western State Highway and all that sort of thing.
That's not one we've necessarily considered, but I think that's probably a valid alternative component. Yeah. Bearing in mind that an
allowed to
alternative.
disagree with the model.
Hmm?
We are allowed to disagree
Yep.
with the model.
Bearing in mind that one of the things about alternative components is that it helps if they come from a defined code list.
Yep. Agreed.
So for things like road, that's very defined. You can define pretty much how that's going to be abbreviated. Probably more difficult to do with that, but
Yeah, certainly that one. But for highway, you may actually need to split that highway component into two, where you've actually got the number as a suffix, so that you can.
yeah, and we discussed that in one of our meetings as well. That's an issue that we have a place where we parked issues, and that was one of the ones where we discussed it and we parked it because we didn't feel that it was something we were going to get to a resolution on that would help us build a profile for the model. But yes, they're all things that we did discuss. Yeah.
We said we'll wait till we have a talk to our reviewers.
The only thing as I said before, I haven't gone through is how we think the parent-child relationships work. Now, I've got a diagram for how I think those parent-child relationships work, but this is an area where we're still a bit unsure about how they work. So this is an area where some more discussion could fruitfully be had. But essentially, if you look at the board at the back, you can have a parent addressable object at the top with parent addresses, and those parent addressable objects and parent addresses can have children or child addressable objects and child addresses. And the example here would be apartments inside an apartment block. So the property that incorporates the whole building would be the parent, a parent addressable object being the property, a parent address being the address for the whole property. Yeah, there's examples next door, just out that window. And then the child would be an apartment address. So the child addressable object would be the physical space that apartment occupies within the building, and the child address would be the address of that apartment. And again, each of those addresses has its own address point. It has its own alias relationship. But we've now introduced the idea that there's a relationship between the apartment and the apartment address and the property address, which is a parent-child relationship. Now, that's in the model as a reflexive relationship, and we're still a bit unsure about how that one translates. So we'd love to have some more discussion about that. Pete, this is where the email came from the other day. Yeah. So any questions, or does that kick people off in a good direction? Paul?
Maybe I can clarify a bit about what's an addressable object, and picking up on this parent-child thing. One of the issues for Dock is we've got a large national park with multiple addresses on multiple roads.
Yeah.
Is that an addressable object? And how do you deal with rapid numbering of various
So what?
operational buildings sprinkled around several TLAs and half New Zealand?
So what we did for addressable object is we went back to the Local Government Act 1974, which defines what you can allocate an address to. And the Local Government Act 1974, 319B, says that you can allocate an address to an area of land, a building, or a part of a building. So we started at that point. That's our start for building a code list of what an addressable object is. Because you can only allocate an address to an area of land, a building, or a part of a building, those are what an addressable object can be in our profile. Now, we may want to pick into that in more depth, but that's a good starting point.
When you say building, it can be a structure.
The Act actually says building.
But what do they mean by building? It could be a structure.
It could be a structure. And in Wellington, for example, substations have address plaques on them. And I know that in some areas, fountains and memorials have addresses, and parks have addresses. But we felt that for the purposes of a draft profile, starting with 319B was a good place to start. But the important thing is the addressable object is the physical thing that's there. It's when you get to where that address is located, and it's what you find when you get there. But yes, we could. There's certainly some discussion to be had around, do we need to pick that into any more detail or not?
I think this is a definition. Often what you say is building.
Yeah, often a structure is on land, so
Yeah.
you can cover it by giving an address to the land that the structure's on.
When this came up the first time, when we first looked at it, and I'm afraid I'm going to have to dive into my law school things here, we actually went through and had a good debate, like we said, on what building, area of a building, or an area of land could be, and that we've sort of come to the conclusion that's a very flexible, open sort of definition, because you can take a very broad approach. You can argue everything from a substation as a building, or a substation as a part of the building to which is attached, like, for instance, the Royal Society of New Zealand, located at, is it 1 Turnbull Street? Or 15 Turnbull Street. There is a substation located there, and there's an argument to be made that, for instance, the substation located on that property is a part of the building, which is the Royal Society of New Zealand, but it's also a part of the area of land, it's also a building in its own right. So that, we sort of thought that keeping it that broad to those three definitions would give us the opportunity to define addressable objects very broadly or very narrowly as we sort of fit in certain circumstances.
I mean, the examples really, the best examples for addressable object, the parent-child relationship would be hospitals, where you have a large block of land with numerous buildings on it, and you may even have residences within those buildings. University campuses would also be another example of where you would have some quite complex parent-child relationships between addressable objects and addresses, and retirement villages is another one where you would almost certainly have a parent addressable object for the whole retirement village, particularly if it's one like, for example, the one in Tawa, which is individual units. I mean, that's an example that often gets used. They're individual units, but they're all in a retirement village with private roads. You know, you have the entire village complex would be a parent addressable object, and then each unit would be a child addressable object. You know, we had some discussions around how far do we go with this model? How far do we go before we're starting to move into areas where the model should be a property management model? So at what point do we say this is where addressing stops and property management takes over? Examples there would be, say, emergency services might not, they would need to know which unit in that residential in that retirement village the call came from, but then there'd be information that might be useful to them that pertains to the whole village, like does the village have an evacuation plan, or where do the services for the village come from? So, but at what point do we say that's in a different exchange model, that goes into a property management model or a emergency services and administration exchange model? But the concept is that the addressable object, I think, would be a window into those other models.
That's exactly right, Mike. I think that's a good overview. Are you comfortable with where you've got to with that,
Yeah.
Mark?
Is everybody here comfortable that that's a good introduction to where we're going next, which is going to be digging more deeply into each of the classes?
And of course we can return to the diagrams and stuff like this. So we've got a room with a modeller's whiteboard at one end, good pictures of the other. Thank you very much, Mike. That's superb.